Alright, hello Trig. Sorry for the delay. I was trying to figure out how to get the recording to get both what I'm writing on here and what I'm doing on Desmos on my computer. I can get it to do one or the other, but I can't get it to do both at the same time. So we're just gonna have to stick with me, Miss P, drawing grass for now. So today we're looking at limits at infinity. And a couple of different things that are going on with those. The first thing that's going on is either our graph is going off to infinity, or it's going off to negative infinity, it's going off to positive and negative infinity somewhere. So we're looking at the limits as that's happening. So importantly, all of these, we're looking at the limits at 0. Your limit at everything else is whatever that number is. So this is your limit at 3, whatever your point is there, that's your limit at 3. The only ones we're really interested in right now are the ones where something is happening and that's not a point. So if we're looking at the limit as we're approaching 0 from the right here, I can get my... Sorry, I got my sides mixed up because your right is actually my left. So this is actually the right. So as we're approaching 0 from the right, well, same thing's going on both sides here. So we're getting closer and closer to infinity. So our limit as we're coming from the right is we're getting closer to positive infinity. Now the same thing is actually happening from the left. So if we have something going on like this, where your left and your right limits are both approaching infinity, your limit as a whole is also going to be approaching infinity. Same sort of thing if they're both going down. So if this is negative infinity and this is negative infinity, then the whole thing is negative infinity. Now, if they're not approaching the same thing, like if I'm getting closer to negative infinity from the right and positive infinity from the left, then your limit as a whole doesn't exist. We don't have a limit there because we're approaching different things from the left and the right. So they're both positive infinity or both negative infinity. That's our limit. If one's positive and one's negative, no limit. Okay, the other thing that's going on is we're looking at our limits as x is approaching infinity. So if I'm looking at this graph, if I have a graph, and if x is approaching infinity, so as we're going off in this direction, then our function is also approaching infinity. Now, it's not always going to be infinity, but in this particular example, it just so happened that as we're approaching positive infinity, this is also approaching positive infinity, and same thing from the negative side. Now, if we had a graph like this, they'd both be positive infinity. If we had a graph like this, they'd both be negative. Okay, so if you have a graph, pretty simple, just what are you getting closer to? If you don't have a graph, and you don't just want to jump right to the step where you just graph it, then we can think about, well, what's happening as our numbers are getting bigger and bigger and bigger? So if we plug in something really, 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 really big, the bigger x gets, the less this 5 and this 1 are gonna matter. Because if I have like 2 million and I add 5 to it, that doesn't really change it a whole lot. If I subtract 1 from it, that's not gonna change it enough to make a difference, the bigger x gets. So if plugging something really, really, really big here, these two are pretty much just gone. And these two are going to be approaching the same thing. And anytime we have a number on top of itself, like if I end up with 4 over 4 or 4 million over 4 million, that's going to be 1. Now, because of this plus 5 and this negative 1, we're never actually going to reach 1, but that's still our limit. So we're still getting closer and closer and closer and closer to 1. Or if we think about what's happening down here, as our limit approaches infinity, if we plug in bigger and bigger and bigger things, both this x and this x squared are going to get bigger. But the squared is going to get bigger faster. Because if I plug in a million squared is a lot bigger than a million. So the bigger this gets, the less this is going to matter. And if I have what's eventually going to be 1 in comparison over a really big number, the bigger we make our denominator when we've got a 1 there, the closer and closer and closer we're going to get to 0. And unfortunately, if I circle 0, it just looks like a little donut there. Okay, so that's a 0 with a circle and a donut. I'm going to eat the donut. need to know. Okay, anyway. Now, these next two I'm going to go through and graph just for fun, just to show you how that works too. Although I'm assuming at this point you know how to graph things on Desmos. So, same sort of thing here. As we're getting bigger and bigger and bigger and bigger and bigger, the less this 5 and this 2 and even this 3x, the less those are going to matter. So what I've really got is 4 times something really big over 3 times something really big. But those two really big things are really just going to cancel each other out because those are both x squares. So our limit we're thinking is 4/3. Now, if you're not sure and you want to graph that to check and make sure, we're just going to go ahead and pop over to Desmos, which I'm going to turn the screen down. Hang on. There we go. That's better. And if we're looking at our graph on Desmos, in order to figure out what's happening at infinity, I'm going to zoom this out quite a bit. And I'm just going to scroll over to something relatively big and click on it. And if you see that, we've got 1.338. And if we go a little bit further out, I don't know if you can see that or not. Probably not. We've got 1.335-ish. Yeah, okay, there we go. Maybe you can see that. So, if you scroll out to something really big and then just click on it, it'll give you an idea of whether what we were looking for was the right thing. So we got 4/3, 1.335, close enough. And the bigger and bigger and bigger you get, the closer you get to that actual limit. Okay, let's do one more of those. So, if we've got, we want the limit as we're approaching infinity of x plus 5 over the square root of x plus 3. And again, the bigger and bigger and bigger and bigger this gets, the less this 5 and the less this 3 are going to matter. So we've really just got x over the square root of x. And if we have something really big and the square root of that something, this is going to be getting bigger faster. So if we have something bigger, and something that's getting bigger and bigger and bigger and bigger, over something that is still getting bigger but not as fast, if our top is getting bigger than our bottom is, sounds like we're going off to infinity, because the bigger we get here, this is getting bigger but not as fast, so it's not going to catch up to the bigger thing on top. So if we want to double check that, we're just going to go ahead and plug that x plus 5 over the square root of x plus 3 into our calculator. I'm going to get rid of that one. And I'm going to hit the home button so it actually takes me back here. Okay, there we go. And sure enough, we're approaching infinity. This is just going up and up and up and up and up and up and up. I don't know if you can see that or not. There we go. Yeah, if we get into using Desmos for anything more complicated than this, I'm going to have to figure out a way to get it to actually show up so that you can see it. But, I mean, if we're just graphing things, you know how to do that. Okay, so that is pretty much what's going on for limits, so just watch out for where we're finding the limit at. So are we finding the limit at a number? Are we finding the limit at infinity? And just keep an eye on that and look for whether we're looking for the left limit, right limit, or whether we're looking for the whole thing. And that is pretty much it. So check out the homework in the description below, and I'll see you in the next one.